Friday. We're going to talk about density today. In 3.2, so far we've talked about metric units, either in person or virtual. On Wednesday, yesterday we talked about temperature, in person or virtual, and you have access to those videos. Today we're going to finish this section talking about density, and Monday we're going to review all three. That way you get a sort of good grasp, hopefully, on these topics before we move on to the last one. So we're going to talk about density. We're going to do some density problems today. I'm going to have an attachment with this video. It will not be an assignment, but it will be the problems that I'm doing, and so you can practice some that we don't get to as well. Okay, but on Monday you will have a quiz over this section. All right, so let's talk about this, and then at the end I've got a little experiment, and we'll see if it works out or not. So hopefully it does. All right, so density. What determines the density of a substance? Okay, so the density of something will tell you whether something floats or whether something sinks. And this is a formula that you need to make sure that you know for the rest of the school year. All right, so make sure that you know density. The density of something is the mass over its volume. And everything has a certain value for density because you can figure out the mass and you can figure out the volume. So if you can figure out the mass of something and the volume of it, you can get its density. Okay. So we have different units for density. The SI unit for density, the second bullet here, is kilograms per meters cubed. And that's because the kilogram, as you should know or you need to know, is the SI unit for mass, and the SI unit for volume is meters cubed. So that's why it's the SI unit for density. But we're not going to use that. We are not going to use kilograms per meters cubed. We're going to use either grams per centimeter cubed, is what you see right here, or we'll go to grams per milliliter. So this compares the density of four substances: lithium, water, aluminum, and lead. And the density increases as you go through here. I'm going to edit this because I know it's not right. I'm going to put it in the calculator first. So 10 divided by 0.88. So this is 11.36. Okay. Let's go with 11.4. Make it neater. All right, back to this anyways. So the density of lithium, if you have 10 grams of lithium and it takes up 19 centimeters cubed of space, generally we use centimeters cubed for solids and we use milliliters for centimeters cubed and milliliters are volume measurements, but centimeters cubed for solids, milliliters for liquids. But you can use it for both because 1 centimeter cubed equals 1 milliliter, as we've talked about already. So as you go left to right here, the density increases. So what this means is lithium would float in water, but aluminum and lead would sink in water. So because they are more dense than water is. So density is an intensive property that depends only on the composition of a substance, not the size of the sample. So going back to last unit, intensive property means it is kind of what it says right there. It doesn't depend upon how much you have, but just what type of matter you have. So the density of water is always 1. It changes slightly with temperature, but it's always 1 no matter how much water you have. Okay, that's what that means. So because of the differences in density, liquids separate into layers. And so in a minute, that's what we're going to do. You see corn oil, water, and then you have corn syrup, and some other ones right there. So as shown at right, the corn oil floats on top of the water because it is less dense. Corn syrup sinks below water because it is more dense. Okay, and if I decide to do a lab next week over this unit, we will look at density and separate things into layers. So here are the densities of a bunch of different materials. Here, the left you have solids and liquids, and the right you have gases. Now notice the units are different. These are all at room temperature, by the way. 20 degrees Celsius is about 70-ish Fahrenheit, so that's room temperature. So if you look, this should decrease in density. So gasoline is the least dense solid and liquid on this list. and as you go up, you become more dense. So something neat to see is that ice has a density of 0.917, whereas water's density is 1, and we can infer that because, you know, when you put ice in water, it floats. And generally, when you put a solid in a liquid, you're going to think it sinks, but that's not always the case. So these are the values here. And gases have different densities, but the densities of gases are in grams per liter, not grams per centimeter cubed or grams per milliliters, because they take up a lot more space. Gases take up way more space than these other things do. Okay, so I'm going to skip that. All right, here's the first example. Calculating density. A copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What is the density of the copper penny? Okay, so you have the mass and you have the volume. Okay, so we know the mass and we know the volume. What we don't know is the density. But we know the density, the units for density are grams over centimeters cubed. And that's going to help us determine what the formula for this is. So it's mass over volume, right? So we go back here. Okay, the mass right here. Well, they also messed this one up too. Let me fix this real quick. And okay, just notice that. Okay, so the mass of a penny is 3.1 grams, and the volume of that penny is 0.35 centimeters cubed. Okay, so if you divide that out, you get 8.8571 grams per centimeters cubed. Now, if you look at the answer is 8.9 grams per centimeter cubed. We don't want this. We want this. It's because these values here, 3.1, that's 2 sig figs. 0.35, that's 2 sig figs. So when you calculate your answer, you have to round it to 2 sig figs. Okay. Can you assume that something with a low weight will float in water? Notice that said low weight, not density. No, you can't, because just because it doesn't weigh that much, that's not going to affect the density. It's going to, and you need to know the mass and the volume of it. That tells you whether it's going to float or sink and whatever you want to put it in. All right, so what we're going to do now is I'm going to transition my camera over to show you some of these calculations, along with this video for you to practice some of these problems. Okay. So for density, we need to find the unknown quantity. All right. So now density is mass over volume. Okay, but that's not the only way you could write this out. There are different ways to write this out. Okay. Meaning you don't always solve for density. Sometimes you need to solve for volume. Sometimes you need to solve for mass. And so we can rearrange this equation. So if we cross multiply, we get dV equals m, d times v over, or equals m times 1, which is what is the denominator of the letter d there for density. And then if we rearrange this to get volume by itself, volume equals mass over density. Okay, these are 3 separate equations that you either need to memorize or you need to take this one and get these 2 from it. All right, so make sure you can do that. So we're finding the unknown quantity here. So we know the density is 3 grams per milliliter and the volume is 100 milliliters. So we need to figure out, hey, what's the mass here? So to figure that out, we need to figure out which one of these equations to use. We're solving for mass. So it's important to use the one where mass is by itself. Okay, so mass is going to be density times volume. Okay, and that's going to be 3 grams per milliliter. And then we're going to multiply that by 100 milliliters. And when you do that, the good news is these things cancel out, which they should. These units cancel out. Milliliters cancels out that milliliters, and you're left with grams, which makes sense because our unit for mass is grams. So that's going to be 300 grams, right? So And then you can go back and you can put those numbers in this one to see if it's correct. 300 divided by 100 is 3, which is the density. So yes, it's correct, right? All right, let's do letter B here. So here we're solving for density. We don't know density. So we can use the one you're probably most familiar with. Density is mass over volume, okay? Mass is 95 grams. Volume is 950 milliliters, okay? Now I should mention this has 1 sig fig. This has 1 sig fig. Your answer needs to be rounded to 1 sig fig, which it is right there. It has 1 sig fig. So that's good. 1 sig fig. Here, this has 2 sig figs and 2 sig figs. So 95 divided by 950. That's going to get you 0.1. But these both have 2 sig figs, so you need to represent this as a number with 2 sig figs. So put the 0 there. Grams per milliliter. Okay, whether you are in person or virtual, you need to understand sig figs. Okay, I've went over it way more this year than I have in the past. Okay, spend more time on it. So you need to make sure that you're going back and looking at it. Okay, because looking at some of those sig fig quizzes, they were not very good. All right, so we need to review that. You need to go through those notes. Okay, it's important for you to do that stuff before you try to take a quiz over something. All right. Lastly, you need to solve for volume here. So we're going to use this formula, mass over density. So volume is 20 grams over 0.5 grams per centimeter cubed. Okay. So 20 divided by 0.5. Okay. You get 40. Now grams cancel out here, and you're left with centimeters cubed as your unit, which is correct because that's the unit for volume, which is what we're solving for. This has 1 sig fig. This has 1 sig fig. So your answer has to have 1 sig fig. 40 does have 1 sig fig. So that's good. Okay. All right. So if you're trying to get a little ahead of the game here, it would be good if you did practice these on your own before we do them. Okay. But you can do whatever you need to. Okay, so find the unknown quantity, convert first to grams or milliliters. There are 1,000 milliliters in 1 liter, so that's going to be 1,200 milliliters. Okay, the reason we need milliliters is because the density of this is in milliliters. There are 1,000 grams in a kilogram, so this is 1,500 grams. And here, this is 520 milliliters because it's that number times 1,000. And that one times 1,000. Put that in the calculator. Don't mess it up. It's 500,000. Okay. So now that we got those conversions, well, those metric conversions are ones you need to know. Let's figure out the mass here. So we need the formula for mass. It's this one up here. Mass is density times volume. Okay, mass, the density is 24 grams per milliliter. We're going to multiply that by 1,200 milliliters. Milliliters cancel out. So 24 times 1,200. 28,800. And that the unit for that, sorry, I messed up there, is grams. Now, we need to round this, okay? We need to round this correct number of sig figs. So to do that, this has 2 sig figs, this has 2 sig figs, okay? As does this, but it should. So this needs to be rounded to 2 sig figs. So that number is going to be 29,000 grams, right? Over here, same thing. We're solving for density. Mass over volume. So let's use the correct formula here. Mass, 1,500 grams volume 100 milliliters. Okay, so 1500 divided by 100 gives you 15 grams per milliliter. This has 2 sig figs. This has 1 sig fig. So you actually have to round this to 1 sig fig. Okay, so the answer is not 15 grams per milliliter. And you'll have to see this, okay? Because you'll get points taken off if you don't round it the correct number of sig figs. This needs to be rounded to 20 grams per milliliter. That only has 1. That has 2. Okay? So maybe you can start seeing why this is a little bit important. And then finally, down here, we're solving for density as well. Okay? So we have 500,000 grams. We have 520 milliliters. Okay? 500,000 divided by 520. You get 961.538465 grams per milliliter. But we don't want that. 500,000 has 1 sig fig. This has 2 sig figs. We need 1 sig fig for an answer. Okay, so if you're going to round that to 1 sig fig, it's actually 1,000. So we're going to have 1,000 grams per milliliter, which, I mean, normally you don't eat, like in normal math, you wouldn't really consider sig figs, but here measurements, you have to do that. Okay, so you have to round the correct number of sig figs here. Okay, so what I'm going to do is I'm going to do this one right here, this next one that you see right here, and the rest of these are going to be assigned as homework over the weekend, along with this Edpuzzle that you're watching right now. Okay, so you'll need to take a picture of it and submit it as well. All right, so let's do these last 1 or 2, whatever I decide. A block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. What's its density? Density equals mass over volume. Okay, 40.5 grams, 15.0 milliliters. Okay, that's mass and that's volume. 40.5 divided by 15.0, you get 2.7. Okay, grams per milliliter. Okay, which is true. That's actually the correct value for the density of aluminum, which we looked at earlier. So, but the thing is, this has 3 sig figs. This has 3 sig figs. This only has 2. So you're going to need to report this answer like this. Right? That's just the way to do it. That is 3 sig figs. That is 2. You need to report it to 3 because they both have 3. Okay. Last one. Mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. The mercury used to fill the cylinder weighs 306 grams. From this information, calculate the density of the mercury. Density equals mass over volume, right? So we're going to write the mass as 306.0 grams. Volume is 22.5 milliliters. 306.0 divided by 22.5. This gets you 13.6 grams per milliliter. This has 4 sig figs. This has 3 sig figs. So this needs to have 3, and it does. So your answer is already correct. All right. So everything I just said, I think I'm going to hold off on these, and I think we'll practice these in class on Monday. So sorry about that confusion. I think we'll practice these in class on Monday to give you a little better of a little more of a practice with this, since we're going to review this section on Monday. All right. So you just need to make sure you complete this Edpuzzle before Monday.